So what we're going to look at now is finding the distance between 2 points on the coordinate plane. So we're going to talk about two different ways. So on a coordinate plane, we can use Pythagorean theorem, which is a squared plus b squared equals c squared. Or you can use the distance formula. So the distance formula is a little bit lengthy, but it is the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So basically the difference between your horizontal distance squared plus your distance between your vertical distance squared. So just to explain that a little bit further, if we start with our Pythagorean theorem over here, we're saying that 2 points are going to be x1, y1, and x2, y2. So if we put those points on a plane, we've got two of them and they're connected. We are basically forming the hypotenuse of a triangle. So remember, on a coordinate plane, your x value is horizontal and your y value is vertical. So this is my C, this can be my A, and this can be my B. So we're saying the distance between my A value is the horizontal change. So that's my difference between x2 and x1. And then my y value, or my b value, is the difference between my y value. So what's the difference between y2 and y1? So we're basically just making our distance formula from the Pythagorean theorem, but if you're given a coordinate plane, you can find it that way, or you can just use your distance formula. So when we run through an example, it might make a little bit more sense. So in example 1, find the distance between points at 2, 3, and -4, 6. We're a little bit off the grid. So basically what we want to do is make a right triangle. And we're saying that my horizontal distance is 1, 2, 3, 4, 5, 6. And my vertical distance is 3. So if we plug it into the Pythagorean theorem, we'll have 3 squared plus 6 squared equals my hypotenuse, or my distance squared. So you can say c squared or d squared. And then we'll just solve it. So 9 plus 36 is going to give me my distance. We know that to solve equations, to get rid of something that's squared, we take the square root of both sides. And because we know how to simplify this radical, we can say that the distance is 3 square roots of 5. We can also approximate it and say that the distance is 3 times the square root of 5. Plug in your calculator and find the decimal. So I'll do that really quick. And we find that it is 6.708. And that makes sense because your hypotenuse is always the longest side of your triangle. If you don't have a coordinate plane, or you don't have a coordinate plane big enough to put your points, you can just plug it into your distance formula. So the first set of points I come to are my x1, y1. Remember, they come in pairs of x and y. The second set of points is going to be my x2, y2. And so using the formula, we'll say x2 minus a -13 squared plus y2, so -5 minus a -9 squared. And you can be really careful and plug it into your calculator and do it from there. You can also simplify it in one more step, just so it's a little bit simpler. So you've got -1 plus 13, so we've got 12 squared, plus -5 minus a negative is plus, so -5 plus 9 is 4 squared. And so we end up with 144 plus 16 underneath the square root. And then we can just simplify it. I don't care if we get decimals here to a 12.65. So your distance between negative 13, negative 9, and negative 1, negative 5 is 12.65. If we look at another example, so we don't have a coordinate plane here. We've got 2 points. So the first that I come to are my x2, x1, y1. My second are my x2, y2. And we'll plug it straight into the formula. So x2 minus x1 squared plus y2 minus y1 squared. It doesn't matter the order, so we could technically say that this over here is x1, y1, and this over here is x2, y2, as long as whatever x value you put first, you put that same y value first, its corresponding y value first. So negative 4 minus 4 is a negative 8. 2 minus 17 is a negative 15. Remember, when we square it, it becomes positive, which is a good thing because we always want distance to be positive. So I'm going to plug that into my calculator. When you plug it in, make sure that your values are inside parentheses. And so for that one, we find that the square root of 64 plus 225 is 17. Sometimes it'll be a whole number, sometimes it'll be a decimal. So let's go back to this idea of Pythagorean theorem. See if we can do it. So example 4, we've got a triangle at negative 3, negative 1 is 1 point. 3, 3 is another point. And negative 1, negative 3 is a third point. And so we are trying to find the perimeter, which means that we need to know the distance of all three sides. So we need to know what RS is, we need to know what ST is, and we need to know RS, ST, and TR. So we're going to have three different distances. You can solve it using Pythagorean theorem or using the distance formula. It doesn't matter. We'll do a little bit of both. So RS, I'm going to use Pythagorean theorem. So I've got a vertical distance of 1, 2, 3, 4 and a horizontal distance of 1, 2, 3, 4, 5, 6. So I'll have 4 squared plus 6 squared equals my distance squared. So we'll have 16 plus 36. And then I'll take the square root of both sides. And since we're just finding the perimeter, there's nothing about making sure that it is in your simplest radical form. So we'll just leave it as a decimal. So we'll say 7.211. ST, we can use a distance formula. So S would be my x1, y1. T would be my x2, y2. So negative 1 minus 3 squared plus negative 3 minus 3 squared. So again, it doesn't matter your order as long as whatever you put first, whatever x value you put first, that corresponding y value is also first. So we'll have a negative 4 squared plus a negative 6 squared. So we'll have 16 and 36 again. And so because 16 and 36 is 52, we're taking the square root of 52 again. We know here that the distance is still 7.211. Which also means that it's an isosceles triangle. So we could mark on our graph that those two sides are congruent. So go ahead and find TR by yourself. You can use Pythagorean theorem or you can use the distance formula. whatever you choose. So go ahead and pause the video. Find it. So whichever method you did, you should have gotten that the distance is the square root of 8, which is about a 2.828. So to fully answer the question, we're asking for the perimeter, so we are going to add all three of those values. And we find that the perimeter is 17.25. Last thing we'll look at with distance formula is if we are given the distance, can we find the missing coordinate? So we're just rearranging the distance formula, really. So we know that the distance is 10. We have an x1, y1, and we need an x2, and we have the y2. So we'll just plug in everything we can in our formula. So we'll have a minus 7 squared plus negative 3 minus 5 squared. Anywhere where we can simplify, we will. A minus 7 squared, we don't want to FOIL that out. We don't want a trinomial in there, so we'll just leave it for right now. But the negative 3 minus 5 squared can be simplified. So we end up with a negative 8 squared, which gives me 64. To get to this variable in here, I've got to get rid of that radical. So we're going to go ahead and square both sides. And we end up with 100 equal to a minus 7 squared plus 64. Now when we do that, now we can just solve. So we'll have 100 minus 64, which gives me 36. We take the square root of both sides. And when we take the square root, we have learned that the square root of 36 is positive and negative 6, but we're just going to use the positive value. And so we'll add 7 to both sides, and so a is 13. I will pause there. Since we have a positive and negative 6, that actually tells us that we can have more than one solution for that a value. So we could have two different points that have the same distance between them. So we could have a distance here, and we could also have a distance here, or any sort of combination there. So that square root of 36 really could give you two different solutions. So it's kind of cool. All right, let's try one more. We've got a distance of the square root of 10. We've got an x1, y1, and an x2, y2. We're missing the y1. And so we'll plug in everything else that we know into the distance formula. So we'll have 6 minus 5 squared plus 1 minus a squared. We'll simplify where we can. And then to get to that variable, we're going to square both sides. Subtract 1 from both sides. When we take the square root, we end up with a plus or minus 3, so we will work both of them this time. Square root. And so we find that a, well, negative a, is minus 1 plus or minus 3. And then to get that a positive, we'll divide everything by a negative 1. So we've got 1, still plus or minus 3 equals our a. So that means my two a values, a could be 4 and a could be negative 2. And you can go back and check and you can see if both of those values work. So it's pretty cool. All right, that's a total distance between 2 points. What if we were trying to find the middle of the points? We've already talked about a midpoint, but now we're doing a midpoint on a coordinate plane. So this is where we are taking the average of our x values and the average of our y values, and it gives us the middle of a segment on a coordinate plane. So this is my formula right here. X1 plus X2 divided by 2. So how do you find the average? Well, that's it. And then Y1 plus Y2 divided by 2. So example 7, find the midpoint between G and H. So we'll say G is X1, Y1, H is X2, Y2, and if we're finding the midpoint, we're finding a new X value and a new Y value. So we'll have -1 plus 9 over 2, and we'll have 7 plus -1 over 2. And so I'll work it all the way out. So you've got -8 over 2 and 6 over 2, and that simplifies to -4, +3. So we can also use Pythagorean theorem here. So find the coordinates of J. If K is 1, 2, it's the midpoint of JL, and L has coordinates for -2. So if we just visualize a little bit, we know J is somewhere over here, the same distance between K and L. So if we use Pythagorean theorem, we'll see how many over we go and how many up we go. So we go over 1, 2, 3, and we go up 1, 2, 3, 4. So from K, we'll go over 3, and we'll go up 4. So we're adding another right triangle in there. So my points for J are going to be -2, 6. So example 9, if we don't have a grid, can't use Pythagorean theorem, we have to solve it algebraically. So find the coordinates B if P is 7, -6, and it's the midpoint. So it's my midpoint X, my midpoint Y. And A has the coordinates -8, -10. So we'll say that's my X1, Y1. We are missing the X2 and Y2. So what we'll do is kind of break our midpoint formula apart. So we know that X1 plus X2 divided by 2 gives me the midpoint X value. So we know X1, we're finding X2, and we know that it all equals 7. So then we'll just solve for X2. So we'll multiply both sides by 2. And then we'll add 8 to both sides, and we find that X2 is 22. And we'll do the same thing to find Y2. So we'll say Y1 plus Y2 over 2 gives me my midpoint Y value. We have Y1, we're finding Y2. The midpoint Y value is -6. And we'll add 10 to both sides, so Y2 is -2. So your other set of coordinates, your points for B, my X comes first, my Y comes second. And so you can logically think about that because you can go ahead and add and check. So 22 and -8 is 14 divided by 2 is 7. And you can also have your Y1 and your -2. So -10 and -2 cut in half would give you -6. So you're good there. And then we'll practice one more time. I'm doing a video. All right, so then if we've got find the coordinates of N, if M is -6, 4, it's the midpoint of NP, and P has coordinates -3, -5. So we'll do the same thing we did in the previous example. So we've got a midpoint X value, midpoint Y value, then we have our X1 and our Y1. So remember that your midpoint formula gives you an X value and a Y value. And since it's a point on the coordinate plane, they're paired together, but that doesn't mean we can't separate it. So we'll do it the same way. So we've we'll start with just our formula. So to find our midpoint of the x value, we'll just take the x coordinates. So we'll have -3 plus our x2 divided by 2 equals my midpoint x value, which is -6. Multiply both sides by 2. And then add 3 to both sides. And so we find that one coordinate is -9. So my x2 is -9. Then we'll find our y value. So we'll have y1 plus y2 over 2 equals my midpoint y value. Plug in everything that we know. Multiply both sides by 2. And then we'll add 5 to both sides, and so we get 13. And so my second endpoint is at -9, 13. And again, you can check it by adding -9 and -3. That gives you -12 divided by 2 is -6. -5 plus 13 is 8 divided by 2 is 4. So we know that we did it correctly. The last one, find the distance and midpoint between W and Y. So you should go ahead and work that by yourself, and then you can check back later and see if you got the correct answer. Good luck.